Broadcasting live from SETI Alpha 6 in the Andromeda Galaxy, this is Mr. C.
Well, happy Aloha Tuesday to you. Remember, in celebration of Thanksgiving weekend, Thanksgiving week being off, 9 days. So an Aloha shirt every day. So I have so much information to go over with you, and a lot of it is about observations in the night sky and early morning sky. I've already talked to you some about it, but I wanted to review that really quick. We're going to have a lightning review round. You should have a white sheet in front of you, so I'm going to ask you. I've got, I think, a pretty cool question here coming up for you. Okay, and my goal is I'd like to get to LS, if we could. I'd like to get to LS10 maybe. So, and then you could review LS6 or 10. We'll see. I'm going to have to hustle. Okay. So lots of things to review about. Speaking of lesson summaries, Mr. Gilbert is going to give you the telescope lesson summary. And I haven't spoken to him about this, but hopefully he's nodding his head now. Hopefully he'll be willing to do a review with you later in the week on telescopes. So hopefully he'll tell you what on lesson summary, I don't know what number it would be, 17 maybe? Yeah? Telescopes would be 17. On LS 17 on telescopes, he'll have you highlight exactly the key points that he wants you to know and pass those on to me so I can include test questions in them. So you know we've got the test, the astronomy test on Friday. Now I'm not going to let you freak out on this. You're going to do well. Like I said, my goal is to make you successful. My goal is to help you get an A or B on this test. You're going to have to try really hard not to. I know I'm repeating myself. So I'm telling you exactly what to review, Triple R. There isn't any other homework at night after school. It's just review the lesson summaries and the things that we go over. I'm trying to, like, here's LS1. I crossed everything out on LS1, and I'm crossing out a bunch of information on the other lesson summaries because it's just too much detail and you won't remember it. But a lot of key things I hope you will remember. So have LS2 at the ready, LS2, and on your white sheet, here's what I'd like you to do. I'd like you to write down, and if you get this right, it'll be a bonus point. So you can hand this in with your name on it and get a +1. It'll take the place of one you've missed in the grade book. But here's what you've got to do. You've got to get, let's see how many, 1, 2, 3, 4, 5. The 5 brightest objects in the night sky in order of their brightness. So are you going to give us a hint on what they are? Sure, I'm going to mix them up. Here they are. These 5, you've got to get them in the right order. So there's Jupiter. There's the star Sirius, which is pointed to by Orion, constellation Orion. So there's Jupiter, Sirius, there's the moon, there is Venus and Mars, those 5. So Jupiter, Sirius, the moon, Venus, and Mars. Put them in the right order. You've got to get all 5 in order, so you're doing that now. You're giving it a shot. Which one is the brightest from Earth? Kind of fun, huh? And then I have something even more interesting to tell you. How could it be more interesting than that? You'll see. You'll see. Okay, I'll give you another 30 seconds. So Jupiter, Sirius, Venus, the moon, and Mars. In order, the brightest on top. Now, if you miss the brightest, I am going to roll my eyes. I'm just saying. This is an eye roll alert. 10 seconds. Mr. Gilbert will watch you put your pens and pencils down. Pens, pencils down. All right, here they are in order. The moon, obviously, first. Brightest object in the night sky by far, the moon. Then it's Venus. Venus is the second brightest object in the night sky. And it's a planet because it's close. Then it's Jupiter. So it's the moon, Venus, Jupiter, then Mars, and then the star Sirius, which the belt stars of Orion point down to, in order. And just for fun, stick the International Space Station in there. It's not a God-created astronomical object, but where do you think it goes? Where do you think it goes? The ISS. So stick it in between. I'll give you that much of a hint. It goes in between a couple of these other bright objects. By the way, be honest here. Don't cheat me on this. Okay, here's where the ISS goes. The ISS is actually the second brightest object in the night sky. So when I tell you about looking for it and going for 5 extra points, I'm going to tell you right now when to look tonight and then tomorrow night. I'm going to tell you where to look and at what time. The International Space Station, by the way, the SpaceX astronauts just went up to the space station Saturday about noon our time. They just launched to the space station. So they're on their way up. So I'm making myself a note. I'm going to show you that launch just for fun. I think you'd enjoy it. I'm going to show you that after I give you the times. Okay, so the ISS tonight, 6:33. It makes a 3-minute pass over Phoenix from the south-southwest. So the south-southwest, from the south and west. And then it's going to go east-southeast. It's not going to be super high, but it'll be up 3 minutes. So kind of keep looking in the south starting at 6:33 p.m. 5 points. I saw the ISS, parent signature, turn it in. Okay? It's pretty neat to see it. If you haven't ever seen it, I think I've had you look before. By the way, the ISS is going 17,130 miles per hour. So it can stay in orbit. That's orbital speed. It's going 17,130. You got to get going over 17,000 miles an hour to stay in orbit if you're orbiting the Earth. Okay, how about Wednesday? Wednesday, if you're writing this down in your lesson planner, maybe on your calendar. Wednesday, it's a 4-minute pass, 5:46 p.m., 1 more minute than Tuesday, and from the south to the east. So the south to the east. Again, I don't think it's super high. So you're going to have to do some looking, but you should be able to see it. Okay? So pretty cool. So you've got points on that. Now I already told you about the 15-point opportunity. By the way, if you have extra time over Thanksgiving break, have a look for all this stuff. So, and I'll try to give you some ISS data on Friday. Okay? So you can look for the ISS if you haven't done it this week. Okay. What am I throwing out there for you? You get 5 points if early in the morning, 6 o'clock, 6 a.m. or before, you spot Orion high in the southwest, and its 3 belt stars point down to Sirius, which is the 5th brightest object in the night sky. By the way, the ISS is the 2nd brightest object in the night sky, but you know, it's a man-made object. Okay, number 2, so it's pretty bright, you can't miss it. So anyway, the belt stars of Orion point down to Sirius. It's really bright, you can't miss it. I think it's kind of reddish, kind of a reddish star. The color of a star is due to the chemicals on it and how hot it is. So anyway, that's early morning. So you've got Orion and Sirius, and then, oh, by the way, Mars in the east. So all of that's 5 points. I saw Mars, I saw Orion, I saw Sirius. 5 points, parent signature. In the evening, 7 o'clock, around 7 p.m., see the following objects. You've got Saturn up above Jupiter getting closer and closer. It's really close now. Remember, it's going to be closer than it's ever been in about 400 years. About the time Galileo was looking at stuff in the heavens with his 20-power telescope. Wow, isn't that cool to think of that? And he looked at the Galilean moons and concluded that the sun is the center, the heliocentric idea. So anyway, you've got Saturn up above and getting closer to Jupiter night by night a little bit. And then you also have in the east, you've got Mars. Now I messed up. It's Mars in the evening, Venus in the east in the morning. What's cool about Venus in the east in the morning, Venus you can compare to the brightness of Sirius. You can compare their brightness. So pretty cool. Okay? So again, I'm telling you, in the morning, Venus is in the east, 6 o'clock or before, 6 a.m. And then you've got Orion pointing to Sirius, so you can compare Sirius to Venus. Venus is number 2 in brightness, Sirius is 5. So compare them. Have a look at them. Anyway, I thought you might like to look at all that. Remember, if you do both of the, you do the early morning observation and you do the evening observation, you do it all and turn it in together, 15 points. Okay? And can you do it over Thanksgiving? Sure. Sure you can. Okay? So anyway, pretty cool. All right, I want you to watch right now the SpaceX launch, just a minute or so. Watch the countdown and the launch of SpaceX. And the SpaceX rocket is using Newton's third law, which is for every action, there's an equal and opposite reaction. So here's again the demonstration of Newton's third law. I don't want to knock the camera down, so I don't want to blow it up too much. So here it is. Action this way, his law of action and reaction. For every action, there's an equal and opposite reaction. So there it is. Newton's third law. Action, reaction, pretty fun. And now go ahead and watch SpaceX. The countdown. Should be kind of cool. Okay, so that launch, so I always loved seeing a launch ever since I was in junior high. I loved watching NASA launches, and especially loved watching launches to the moon during the Apollo space program. Apollo to the moon. So anyway, pretty cool. All right, lightning round. Lightning round, here we go, LS2. So turn to LS2 in your packet. Lightning round. I'm just going to review with you again very quickly LS2 through 5, and then we'll make some progress in 6 and 7 and so on. Okay, LS2, here we go. What do you call, here it is, What do you call an object spinning like the Earth is doing right now on its axis? Rotation. That would be rotation. Of course, that'll be on the test. What do you call orbiting like the Earth is doing now, orbiting the sun, or the moon orbiting the Earth? What do you call that? Revolution. So that's on the test. You should have circled it. I circled those two. Those are the things you don't have to know. And then also I'm going to ask the 2 reasons for the season. There they are right there, the 2 reasons for the season. The Earth's tilt and its revolution. That is it on LS2. LS3 now, lightning round. Here it is, LS3. So you should have circled all these things. You're looking at LS3 and making sure you've circled these. What do we call a push or pull? A force. Circle that. So what do we call the force that pulls objects toward each other? Gravity. So I circled that up here in the top box. So that's been circled. I'm going to ask you this. I've got it starred. The strength of the force of gravity between 2 objects depends on 2 things. Here they are, the masses of the objects. And how close they are to each other. We went over that yesterday. What do we call the number of atoms that an object has? Say it out loud. Mass. I've circled it there. What do we call how hard you are pulled toward another object? That would be weight. Newton's universal law of gravitation said this. His universal law of gravitation, all objects in the universe pull on every other object, depending on their mass and how close they are to each other. Okay? And then down here you've got Newton's first law, right down here. Newton's first law of motion. What does it say? An object that's moving will keep moving in a straight line until acted upon by a force. An object that's at rest will stay at rest until it's acted upon by a force. So that was LS3. LS4 now. LS4, lightning round, here it is. Phases of the moon, these are the ones I want you to know. Only 4 of them. I'm going to show them to you. Phases of the moon, here we go. Right there, first phase of the moon, when we look at it and it's dark, what is it? Say it out loud. New moon, that's right. 1/4 the way around, what do you call that phase? First quarter. Totally lit up, what do you call it? Full moon. 3/4 the way around, what do you call it? Third quarter. Okay, third quarter. So new moon, first quarter, full moon, third quarter. Those are the phases of the moon that I want you to know up in the top box. Okay, eclipses. An eclipse is where light is cut off by one body. Sunlight's cut off. Like right now, the moon is cutting off light from the sun to the earth. So on the earth, if you're in the shadow of the moon, you can't see the sun. It's covered up by the moon. So that's a solar eclipse. Solar, highlighted, it's on LS4. An eclipse is where a third object casts a shadow. And then this kind of eclipse right here, where the earth cuts off light to the moon. So it's the moon's light that's cut off. So that's lunar eclipse. All right, that's it. And then down below, X out those things, down below. That was LS4. LS5, how are we doing? This is it on tides. This is it, LS5. Tides are caused by the gravity of the moon and the gravity of the sun tugging on the Earth's ocean and causing a bulge. The ocean actually pulls out this way. I don't know the exact number of feet, But as the Earth rotates, you rotate into the bulge, so you're getting higher, higher, higher tides. Then you rotate out of that bulge and lower, lower, lower tides. Higher tides, lower tides, rotating in and out of the bulge. And I'll leave it at that. Those are tides. LS6, lightning round continues. Oh, we haven't done LS6. Okay. The moon. You're going to highlight these things. What is the moon like? What is the moon like? You're seeing the surface of the moon right now. So I'm making myself a note. And you're going to highlight on LS6 the following things. We're doing great. You keep hanging in there. Do you want to do well on the test? Of course you do. So mark up your lesson summary 6. Here it is. What is the moon like? It's dry, it's airless, it's small, all of those things right there. Dry, airless, small. Down below, what do you got? Down below, you've got the maria, circle it. You've got the craters. What are the maria made of? Those are the smooth, dark areas. You can see them on that picture. Those are lava flows, long time in the past. Not that long ago. Thousands and thousands of years ago. Okay, so the maria, M-A-R-I-A, maria, it means oceans. Do you remember that? The ancients looked at the moon and thought, those are oceans of water on the moon. Well, when we turned our telescopes to the moon, like Galileo, and then after that, we go, no, 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 they are not oceans of water. And we determined they're oceans of lava that cooled. It was liquid lava that ran across and smoothed out the surface in those areas and then cooled and hardened. So maria, lava. You know how you might remember LM? The lava part of the moon is the maria, LM. Lava, maria, LM. I'm just saying. I put an L right beside maria, LM. Lava formed the maria on the moon. Then you got your craters formed by meteorites. Meteorites that hit the moon and made a hole. Those are craters. The moon is heavily cratered. Okay? The moon is only right up here. The moon is only 1/4. Look where I'm pointing. 1/4 the diameter of the Earth. So it's like 1/4 size of the Earth. 1/4 the diameter. No atmosphere on the moon. No atmosphere. It's got 1/6 gravity. So on the moon, you'd weigh, if you weigh 100 pounds on Earth, you'd weigh about 16, 17 pounds on the moon. Isn't that weird? So that's why the astronauts can bounce around even though they've got 200-pound spacesuit on. They can bounce around like they're really light. So 1/6 the gravity. So, and because there's no air and it's a slow rotator, plus 275, minus 275 Fahrenheit. Woo! It's a hot one and it's a cold one. Takes about 28 days to rotate. Slow rotator. Slow rotator. No air to hold in the heat. So at night, the 14-day night, the temperature drops to minus 275. So like a 550-degree temperature swing. Because, two things, slow rotator, and I wrote that beside the temperature, slow rotator, and no atmosphere, no air. It's not a good place to live for humans and for plant life and for animal life. Okay, I think that about does it for the moon, LS6. Okay, LS7 now. Rockets. Okay, not much on rockets. So we're going to do LS7, and then probably LS8, and we'll see how we go. Maybe LS9. We've got to hustle, though. We'll see. All right. So I already showed you what a rocket is. A rocket is a device that expels gas in one direction and it moves the other way. Newton's third law of motion. For every action, there's an equal and opposite reaction. Okay. So action-reaction law. And then, so up above in the top box, you've circled rocket and which country developed rockets first. Fireworks, probably, first. China. So see up there on the top, I've got China. So action, reaction. That's the top box, rocket, China. That's it. Okay. And then, what do we call the gas? There's a name for the push that comes out the back end. We call that thrust. So thrust right there, thrust, thrust, thrust. Just the reaction force that propels a rocket forward. So it's like action, reaction, thrust. Okay. And then it makes the rocket get going a certain speed. That's called velocity. So up here you've got velocity. Velocity. And then there's two kinds of velocity that I want you kind of remember. There's going fast enough to stay in orbit. I think you already talked about it with the ISS. I did. And to get going fast enough to stay in orbit, what velocity or speed do you call that? Orbital velocity, and it says that right there. Orbital velocity, can you see it there? Orbital velocity. And then escape velocity. When we sent our astronauts to the moon with the Apollo project, they had to get going 25,000 miles an hour. Orbital velocity is 17,000 miles an hour. Okay? Velocity is your speed in a given direction going into orbit around the Earth. Orbital velocity, escaping the Earth's gravity, escape velocity. Okay? And then you don't have to write any of this down, but here's a bonus. Newton's second law. His first law, remember, an object at rest or a man at rest, an object in motion will stay in motion, less acted upon by a force. Okay, you already know the third law. For every action, there's an equal and opposite reaction. His second law was F equals ma. F equals m times a. This will be a bonus point. You see it down there? F equals m times a. F is force. Force, the force that an object has, depends on its mass and then times its acceleration or its speed. F equals m times a. That'll be a bonus point on the test. I'll stick it in there as a bonus point. So you can get +1. It'll take the place of one you miss. Newton's second law of motion. F, that's supposed to be an F, for force. The force of an object, like a rocket, depends on its mass, how many atoms it has, times its speed or acceleration. Now, this will blow you away. I was going to bring a baseball because I used to be a baseball pitcher. A baseball weighs, I think it was 5 pounds, 4 ounces, like a Major League Baseball. Okay? And really good Major League pitchers, what kind of velocity do they get with that baseball? 100 miles an hour. So it's got 5 ounces and it gets moving 100 miles an hour. If you get plunked with that, like in the back, I mean, it's going to leave a really bad mark because it's got, pretty good force. That's nothing. Listen to this. The Earth, I didn't even bother to look up the weight of the Earth, but get this. The Earth's velocity around the sun What do you think it is? How fast do you think the Earth is going around the sun? It's got to go this fast. It's its orbital speed, or it'll be pulled in by the sun if it slows down. Or if it gets going faster, it'll fly away. So God planned it just right. The orbital speed of the Earth is 66,600 miles an hour. Not kidding. Why don't we feel the speed? We're all going to fly off. Because the Earth's gravity and everything is moving with us on the Earth. So even though we're rocketing through space at 66,000 miles an hour, we don't really notice it. How about this? How about the sun's orbital speed around the center of the Milky Way galaxy? This will blow you away. What is the orbital speed of the sun around the Milky Way galaxy? 500,000 miles an hour. Shocking. 500,000 miles an hour. That's how fast the sun is moving through the Milky Way galaxy. Wow. Now, did God plan the speeds of every star in the Milky Way galaxy? 100 billion stars. You bet. He had to plan the speed of everything. It's not an accident. It couldn't have evolved accidentally. All those orbital speeds are just right. So, all right, that's LS7. LS8 now. We've got to hurry. LS8. This is the history of space exploration. And at the top, I want you to put the Soviet Union. That's Russia. They were the first to put a satellite in space. So do you see Soviet Union up there at the top? Soviet Union put the first satellite up. And then highlight satellite, just an object that revolves around another one. I've already told you about our Go to the Moon project. It was called the Apollo project, but I'm not going to ask you that. The Apollo project. But right now we've got satellites in orbit. We put up space shuttles that go up to the space station and then come back. So you're going to circle space shuttle. Then over on the right, you're going to circle space station, a large artificial satellite where astronauts live on board and do space experiments. And then down below, space probes and rovers. So there's, let's see, 5. So there's 5 of those space objects that you've got to circle. Satellite, space shuttle, space station, space probe, and rover. And do you see what I put there in red over there on the side? Won't that make a great matching part of the test? So I'll put those terms down. It'll be a matching. Woohoo! So will that make it easier? Sure. So satellite, space shuttle, space station, space probe, rovers, and that gets us through LS8. Okay? Alrighty. And then looking at LS9, we'll wind up with LS9 and we've got to hustle. At the top, 2 things that space is like. You already know it's a vacuum. There's no air. At the top, see that? Vacuum. And microgravity, no gravity in space. So that's what it's like on the ISS. It's a vacuum and microgravity. And then down in the middle box, you've got a space spin-off. All a space spin-off is something that was developed in space, and now we use that technology to make something on Earth. And I'm going to give you 3 or 4 really quick, and you can write them down. I'll probably ask for 2 space spin-offs. See that? A space spin-off. See that right there? A space spin-off. One is memory foam, like in mattresses. chairs, shoes, like walking shoes or running shoes. They're made of memory foam. It'll push down, but once it's not being pushed anymore, it'll bounce back into the same shape. Memory foam. Here's another one, scratch resistant. I don't have my sunnies with me, sunglasses, but scratch resistant lenses or sunglasses is another one. Anything else? Cordless vacuum cleaners, LED lights that are used to keep people awake in a workplace. So LED lights, special clothing for space that's thin but warm. It's light, thin, but still keeps you warm. So special clothing, cordless vacuums, memory foam. How many do you need? You only need 2. Okay? So we got to LS9, so you're going to review 6, 7, 8, 9 tonight, and then the others. Don't forget Psalm 19:1, the heavens declare the glory of God, the sky above proclaims his handiwork. You look out into space, and it brings God a lot of glory because he spoke all of that stuff into existence instantly. Just into existence instantly. Okay? Well, anyway, there you have it. Turn you over to Mr. Gilbert. He's got a few minutes left, I trust. And study Triple R for your Friday test. You're going to do well. So I'm praying for you. I know you're going to do well. But you got a Triple R. Talk to you tomorrow. Adios.